Nice. Good. Thanks for catching that. Um, and then, so potassium is the last nutrient we'll be considering today. And for our purposes, I really just want you to kind of catch that potassium is sort of in between nitrogen and phosphorus in terms of solubility. So we won't see it leaching out as much relative to nitrogen, and it will be a little less likely to build up in the soil relative to phosphorus. So and in the one real management consideration to think about when thinking about avoiding getting too much potassium in your soil is that plants respond to high soil levels by accumulating potassium in their plant tissues, which can be a problem, especially if you're growing a forage plant, because that can become detrimental to the health of animals consuming that forage. Cool. And while we aren't going to get into the weeds too much on liming soils, this is a good point to remind ourselves that nutrient availability is tied to the pH of the soil. And generally, vegetable crops perform best between a pH of 6 and 7.5. And although there are exceptions, and this chart indicates how the availability of different nutrients varies with pH. And you can see there's definitely a sweet spot in terms, like the width of the band indicates availability, and you can see there's definitely a sweet spot between 6 and 7.5 about. So, and this is also the range that makes the soil microbiology is happiest. So that's another win for really paying attention to your pH levels, because with organic amendments, the health of the soil microbiology is key, because we need them to keep things cycling and decomposing and working on those organic amendments. And I did include in your resources folder that a really good publication from OSU that walks you through all the pieces of evaluating your pH and how much lime to add to change that pH, move the needle on that. All right, so with this quick review of nutrient cycling behind us, let's get into setting up a nutrient budget. And as we walk through the steps, I'm going to introduce you to this simple spreadsheet calculator I've been working on. And while it's totally not necessary, maybe you're like me and it helps to have all the information in one place and have adjustments calculate through automatically as you're kind of evaluating different amendments. So the spreadsheet again is in that shared Google Drive, and you're welcome to bring it up now if you like. So this is a screenshot of the main tab in the calculator, and the first section is the soil test analysis section that it'll allow you to enter values from your soil test. And then next is a section where you can enter what amounts of each nutrient are recommended, and or what amounts of each nutrient we would expect our crop to take up. And we'll walk through several resources for where you can find these recommendations for different vegetable crops. And from there, you'll be able to, you'll be set up to enter values for different nutrient sources. So that's this nutrient additions section. And we'll also walk through how to know what to enter here based on characteristics of the organic amendments we'll be looking at. And so the calculator will take all these values and calculate a nutrient balance down at the bottom. So that's kind of what we're the whole goal of this little spreadsheet calculator, and of course nutrient balancing. So let's see. Oh, and I should also note that the green cells in the calculator are where you would be entering different values. Of course, it's not a locked spreadsheet, so you can play with it in whatever way you want, but just as a little bit of a guide, the green cells are where you can enter the values that you need to have the calculator crunch through the and get a nutrient balance. So first, let's look at the numbers for your nutrient budget that are pulled from the soil test. So this is a sample soil analysis report. And down at the bottom here, I've just pulled the cells from the calculator where you would be entering the values from the soil test. And so the first thing you'll want to look at is the nitrogen, and notice that the nitrogen, we usually ask the lab to give us a report of nitrate nitrogen, remembering that that's the form that's most available to the plant and most easy to measure in the soil. So that's why we ask for the nitrate nitrogen. And for our example, that's 8, so it's pretty low. So we'll pop that into that field for nitrate nitrogen in your calculator. And next, we'll look for the phosphorus level in the soil. And here on the west side, we always use the phosphorus weak Bray value. You see there's 2 for phosphorus, but we always use the weak Bray. So you pop that into your calculator down below, which is 38 is pretty high. And then finally 82 would be what you would pull for your potassium for this example. And you would pop that into your calculator in the value for K. So, and note that those units are all in parts per million. That'll be kind of important later. Next, you'll want to also pull the organic matter percentage from your soil. So that's found here, and this soil is coming in at 3.7% organic matter. And we want to put that into the calculator because the calculator will then do a calculation to figure out, well, how much nitrogen are you going to be able to count on from the organic matter? How much will the organic matter release for your crop? And that's everything for the soil test analysis values. And the next step is to figure out what nutrients you can expect your crop to uptake through the season. And there are several resources that I find especially helpful and complete, and those are also in your resource folder. And they all have tables with recommendations for nitrogen, phosphorus, and potassium for different vegetables. And I've also put some links to them, each of these 3 guides in a tab in the calculator. So if you're wanting to access it from the calculator, you can do that from there too. So this one here, the Soil Fertility and Organic Systems, is by Doug Collins, and he's right here in Puyallup at the research station, and it's a really helpful guide. This one from Minnesota is super detailed. It's a really long and full of detail, and you can really nerd out with this one for sure. And then this online resource is the vegetable production guides from OSU, and they have a link for each vegetable and will give you complete growing recommendations, including fertilizer recommendations for each vegetable. And of course, that one is regional, so it's especially helpful for us growing out here. So here's a screenshot from the OSU vegetable nutrient guide, and I've pulled up the one here for Brussels sprouts. So here the guide is suggesting 150 to 200 pounds of nitrogen for Brussels sprouts. So that would be the number we would pop into our spreadsheet for nitrogen. And for phosphorus, it tells us if the soil test P reads within this range here, 30 to 50, we were at 38, then you should apply a corresponding amount in this other column. And since our soil test P is in the middle of this range, we'll go with an application amount of about 125. And then next for the potassium level, ours came in at about 82, so it would be in this range here. And so the guide tells us we should apply between 150 and 200 pounds of potassium. So that would be the, we maybe would plug in, say, 175 for that, for this, for our example in our spreadsheet based on our soil test. So there we go. That's where you pop it in here to the spreadsheet or whatever calculator you're using, or if you're doing it on paper, that's where the values that you would be basing those would be the goals for how much you're trying to add to the soil, make available for your crop. Let's see. And I just wanted to take a few minutes to point out a couple small details that are small but important. So we've noted that the nutrient values on your soil test are reported as parts per million. And I do have a function in the spreadsheet that will take the soil test nitrate nitrogen and make a prediction of how many pounds per acre of nitrate nitrogen would be available to the crop. However, it's best to take these predictions for nitrogen with a grain of salt. As we've noted, that nitrate nitrogen is very leachable. And so depending on when your soil test is taken and how much rain falls between then and your cropping season, that nitrogen may or may not be available. So it's just good to kind of remember that and not necessarily count on it, even though you can add it to your budget, but just remember that it's a little fluid. And then in regards to phosphorus and potassium soil test levels, from the soil test, they're not necessarily an indicator of how much phosphorus and potassium are present and available to plants. You can't just make a calculation based on soil test level and say, this is the amount of phosphorus and potassium that's available to the crop. Rather, researchers have sort of documented a relationship between crop yield and extractable phosphorus and potassium levels from the lab. And they've used those to develop indices to predict whether the availability of these nutrients will be low, medium, high, or excessive. So just kind of helpful to keep that in mind when you're using these guides to figure out how much phosphorus and potassium you want to add to your system. So in that OSU guide that we just looked at, when they suggest how many pounds of phosphorus and potassium to add based on soil test levels, they're relying on those researched indices for our region. So that's helpful. And it's also good to note that fertilizer labels and fertilizer recommendations, we talk about them as phosphorus and potassium, but they are actually noted as phosphorus is noted as P2O5, and potassium is noted in units of K2O or potash. So there's no real good reason for it. It's just a convention that goes back to way back when they started talking about fertilizer labels and recommendations. But it can confuse your calculations if you're not tracking that and you come across a fertilizer label that doesn't follow the convention, and maybe they'll note that, but you can assume that they're using the convention unless they say otherwise, but it's good to maybe read the fine print sometimes. So a bag of fertilizer labeled 5-10-10 will be 5% nitrogen expressed as just nitrogen, and then 10% phosphorus, but expressed as P2O5, and then 10% potassium, but in units of K2O. So And because fertilizer recommendations also follow this convention, it's usually not a problem, but just be aware of it. And it might be good to just double check, because a lot is at stake when you're figuring out how much to apply of each of these nutrients. All right. So now that we've noted our soil test data and established a goal for what we are aiming to provide our crop, we're ready to figure out, well, what nutrient credits can we count on from our soil, and what amendments will we need to add to make up the differences. So first, depending on whether you choose to factor in nitrogen credits from your soil test, the spreadsheet calculator will convert your soil nitrogen levels from your soil test to pounds of nitrogen per acre. There, where that's circled in red there. And then let's look at what nitrogen credit we can expect from our soil organic matter. And one rule of thumb that we use with the NRCS, that they've the guidance that they give us when we work with their programming, is to estimate plant available nitrogen from organic matter at 10 pounds of nitrogen per acre for every percent organic matter from your soil test. So that's what I've plugged in to the calculator here. And I've noted that there in case you forget what the calculation is based on. But the guide that I mentioned there from Doug Collins, the Soil Fertility in Organics Systems publication, he notes that from soils that are organically managed typically provide between 40 and 200 pounds of nitrogen per acre. So that's quite a bit higher than that estimate of 10 pounds per every percent of organic matter. So that's just another recommendation, and you can override the calculation here if you choose, especially if you're starting to observe that, wow, I think I'm getting a lot more nitrogen from my organic matter than this calculator is predicting. So, and of course, tracking organic matter has value beyond just estimating what nitrogen will be available to our crop. Organic matter levels are great indicators of whether our soil quality is improving or degrading. And as soil organic matter increases, water holding capacity and the microbiological activity increases in our soil. So it's a great thing to track, and can be a great guide for how am I doing managing my soils. And one good piece of information to have when you're evaluating that potential role of organic matter for your soils is to learn what typical ranges are for your soil. And you can find this information for your soil type by looking up your soil on the NRCS Web Soil Survey site. And I've included instructions in your shared folder on how to do that. So it's a little bit of an overwhelming website, but once you kind of get the hang of it, it has a ton of great information, and you can learn a lot about your soils there. So here I've pulled up soil reports for two different really wonderful soils in Pierce County. The first one here is a Puyallup fine sandy loam, very common for us here. And then another one, the second one here is a little bit heavier cindery sandy loam. This is a soil out by Mount Rainier, hence the cindery sandy loam. And they're both wonderful soils, but you can see that here they've noted what this soil type typically has in terms of organic matter in at different levels. So here it's 0 to 13 inches. They say, well, this soil, if its organic matter is low, is at 3%. A medium range is 6%, and then this soil can get as high as 9% when it's at its the higher range. But then this heavier sandy loam for it, the low organic matter reading is way up at 5. And it can, they suggest that it typically can go as high as 10. So it's you can see that a heavier soil just will tend to be able to sustain higher organic matter levels. So it's just good to kind of know this about your soil so that you have kind of realistic expectations of how much can I build my soil, and when will I know if I've gotten there to where I want to be. Um, so here you can see that if both of these farmers had achieved 5% organic matter, the Puyallup sandy loam farmer would be feeling pretty good. He's well within that medium range for organic matter for his soil. But the farmer from who has the cindery sandy loam would feel like, yeah, it's realistic for me to push even a little further than 5, because 5 is actually kind of low for my soil. So it's just a helpful tool to kind of situate yourself and get a feel for what your goals could be for soil organic matter. And it's also important to note that an increase in soil organic matter of even just a couple percentage points is really considered large. The amount of organic matter in the soils is really huge in comparison to what can be added via annual plant biomass inputs. So the total soil organic matter changes very slowly in response to management changes, and it can often be 3 or 5 years before you'll really see an increase in soil organic matter following a change in management. So that's good to just be aware of as you're setting your goals for your soils. So so the next value to input into our credit section is the nitrogen that we might expect if we were going to be growing a cover crop. We've left a piece in there for inputting how much nitrogen you could expect from a cover crop. And of course, incorporating cover crops into your system has multiple benefits related to your nutrient budget. Cover crops cover the soil through fallow periods and provide those living roots for soil life, like the mycorrhizal fungi that we just finished reviewing. And that has implications for phosphate uptake. And cover crops can also help retain nutrients that might otherwise leach out of the cover crop zone during fallow periods. And of course, they build soil organic matter, which can enhance overall nutrient cycling in the soil. And the nutrient additions to the system by cover crops may be longer term via their role as soil organic matter builders. On top of all these benefits, depending on what cover crop you select, cover crops can supply nitrogen to a subsequent crop, actually add nitrogen to the system, because legume cover crops are actually able to pull nitrogen from the soil air, the atmosphere, and incorporate it and make it available to plants. So cover crops can be one of the few organic inputs that can supply nitrogen without also supplying additional phosphorus or potassium to the system. And in our region, where many of our soils are already high in phosphorus, this is an important advantage. However, there are several key concepts to consider that will determine whether a cover crop will add nitrogen to the system or take away nitrogen from the system temporarily, or whether there will be no net gain, neither a gain or loss of nitrogen. And this publication from OSU, estimating plant available nitrogen release from cover crops, is a really great guide to understanding how to predict how much nitrogen you can gain from a cover crop. And what I'd like to do next is just walk through the basic concepts that they cover, And you can dive more deeply into it, of course, by reading this guide on your own later. So let's take a look at a few of their key concepts. So first, it's important to understand how the carbon to nitrogen ratios in cover crop biomass fluctuate as the cover crop matures. As the seed to N ratios fluctuate, the plant available nitrogen from the cover crop matches that fluctuation. So this figure shows how plant available nitrogen fluctuates as different cover crops mature. And so the y-axis here is just showing the plant available nitrogen against the x-axis of when the cover crop is terminated and then incorporated into your soil. And they've graphed out here the fluctuations for a cereal, and then also just for a legume cover crop. And then a black line here is a mix, which is more legume, and the blue line is a mix which is dominated by cereal cover crops. So let's take a look at this red line first. So you can see here that the joint stage of the cover crop is, and that's the point at which the cereal really begins to invest in its reproductive phase, and goes through elongation, really starts to take off. And boot stage here is when the seed head of the cereal really starts to swell in that flag leaf sheath, but it hasn't quite emerged yet, but it's just about to go into flower. So as you can see, cereal pan decreases when it reaches the reproductive phase, and nitrogen is actually immobilized, or basically is unavailable to the crop. But contrast this with the legume in the green, with the green line, and you can see that for a legume cover crop, the pan ratio, it just simply just continues to increase at the bud stage. So you can see the importance of allowing that legume cover crop to go as long as it can until flowering. You'll get more and more nitrogen as the crop matures. So what is happening in the soil that accounts for these fluctuations in nitrogen availability? So most decomposition of the incorporated cover crop occurs in the first 4 to 6 weeks after plowdown. And as the soil microorganisms decompose the cover crop residues, a portion of the cover crop is lost from the soil as carbon dioxide. The remaining cover crop carbon is transformed by the decomposition process and yields fresh soil organic matter with a C to N ratio of approximately 12 to 1. And for a typical cover crop, 60% of the cover crop carbon is lost as carbon dioxide, and 40% of the carbon from the cover crop is incorporated as soil organic matter. So that sort of happens across the board for all cover crops, regardless of whether they're cereals or legumes. So like I said, the microbes are responsible for this decomposition process, and as they do this work, they also have nitrogen requirements. So for a legume cover crop, like say a vetch, that is high in nitrogen, maybe 3 to 4%, about half of the cover crop nitrogen will be released as plant available nitrogen, because the soil microbes have more nitrogen than they need to build that soil organic matter. So there's extra, and it is released into your soil. It's available to your plant. For non-legumes, such as cereal rye, that may just contain 2% nitrogen during that stem elongation phase, the release of plant available nitrogen is small, because most of the cover crop nitrogen goes towards the work of microbes in building soil organic matter. And then, of course, when the cereal reaches that boot stage and starts to head out, it's nitrogen levels drop to say 1%. And then at that point, nitrogen is actually immobilized because the microbes are actually scavenging nitrogen from the soil to do the work of decomposition. So they actually, the availability of nitrogen goes negative. So those are all important dynamics to understand as you're thinking, well, what do I need to add to my nutrient budget depending on what my cover crop is doing, or what I can expect it to what I can expect it to do in terms of influencing the soil nitrogen levels. So so all these interesting dynamics make estimating the effects of a cover crop on a nutrient budget somewhat imprecise, as you can imagine. And it may take years of observation to figure out what exactly you can count on from cover crops. But being aware of the potential influences will allow you to adjust your system appropriately over the years. And the publication from OSU is helpful in two ways. It covers some of the basic rules of thumb extrapolated from their research in terms of what you can expect nitrogen-wise from a cover crop. And you can use their figures to estimate what you might expect the nitrogen contribution of your cover crop to be. But if you'd like to dial things in more precisely, it provides a step-by-step guide to sampling your cover crop and submitting samples to a lab, and then you can really determine more precisely what your cover crop is providing. So, and a companion resource to the OSU guide is the organic fertilizer and cover crop calculator from OSU. And there is a link to this calculator as well in your Google Shared folder. And this calculator you can use to enter the values you obtain from that process that you might choose to follow to sample your cover crop and send it into a lab. And then you can enter those values into this calculator, and it'll spit out an estimate of how much nitrogen you can expect from your cover crop. And I've also included the calculations in a tab in the spreadsheet from PCD. So you have that there. You can crank through those on your own without the calculator, and it's right there for you for easy reference. So, but if you don't want to go through all of that lab analysis and sampling, you really just want a general estimate for nitrogen contribution, the OSU guide does suggest the following. So they say that a legume cover crop, you can count on it providing up to 100 pounds of pan per acre. And like we talked about, you want to allow that cover crop to grow as long as possible to bud stage to get the most bang for your buck, because the nitrogen in the legume will just accumulate until that stage. So that's when you should terminate that cover crop. And they suggest that cereal crops, you should count on them actually immobilizing about 50 pounds of plant available nitrogen per acre. But to minimize this, of course, you're going to want to terminate that cover crop early during stem elongation. So within this range here, before it really starts to suck nitrogen out of your system. They note that legume cereal cover crop mixtures really do provide a wide range of plant available nitrogen contributions, depending on the legume content of the mix. They say that, in cereal legume mixtures, the best crop growth stage for maximum plant available nitrogen really depends on the percentage of legume in the stand. So when the cover crop has mostly legume, you can see from this diagram or from this chart that it really does behave much the same as a pure legume stand would, just increases in nitrogen steadily up to a certain point, but that the pan from crop residue will only increase until the cereal part of that stand reaches boot stage. So you're going to really want to keep an eye on the cereal part of that mix and terminate it at that point. So that's going to be, you're going to get a little less nitrogen, but if you can keep an eye on things and terminate it at that right point, you're still going to get a net gain of plant available nitrogen. Then when a cover crop has more cereal than legume, it follows a similar curve to the cereal stand alone, but you can kind of extend you can extend the life of your cover crop a little bit because you'll have a little bit more wiggle room before the plant available nitrogen will start to decrease. So and that again would be at the boot stage for the cereal. So I hope what you can take away from this is that if you seeding legume cereal mixes rather than a solo cereal crop will allow you a little more flexibility in terms of the timing of terminating that cover crop. So that's one good neat advantage of doing a mix. A classic issue with us here in the Pacific Northwest is that you have a cover crop out in your field and it's at a point where it really needs to be terminated, but maybe it's just too wet to get out there. So if you have a cereal crop, cereal cover crop alone, you're going to have a little bit less wiggle room. You're going to have to terminate that early, but and maybe you won't be able to get into your field on time. But if you take the approach of seeding a mix, you're going to be able to extend that window a little bit and be able to have a little bit more flexibility in terms of timing of termination. So, so circling back to our spreadsheet calculator, this is where you're going to be able to enter an estimated amount for nitrogen contributed by a cover crop. So say we grew a nice all legume cover crop, we might expect to get 80 pounds of nitrogen per acre from that cover crop. So so now we're coming to the point in our balancing process where we're ready to look at organic amendment additions. And in the spreadsheet, there's a cell to indicate here where what your fertilizer type is. You can put that in under the first column, and then you can also enter the analysis for what does the bag of fertilizer say in terms of what is what the NPK value of that fertilizer is. And from there, you can enter the values for how many pounds of each nutrient will be added based on that analysis. So you can input the rate for each amendment added here, and then the spreadsheet will calculate the nutrient contribution of that amendment in the system. However, this is where things get tricky with organic amendments and nutrient balancing. It's one thing to know the analysis on your organic fertilizer label or your manure test, but because of the unique characteristics of organic amendments, the nutrients contained in the fertilizer, according to the analysis, may actually not be all available to your crop in that season. So what are some of these characteristics of organic amendments that make life tricky? Organic amendments are like natural materials, obviously, in the soil that release their nutrients through those natural processes in the soil. And the rate of release of nutrients from those organic amendments really depends on the activity of soil microorganisms, as well as temperature and moisture conditions. And relative to processed fertilizers, organic fertilizers usually contain smaller amounts of nutrients, and they release those nutrients more slowly. And they have nutrients that are immediately available, as well as slow release nutrients. And some of the material in organic fertilizers is released so slowly that the nutrients are not even available during the first season after application. Another complicating aspect of organic fertilizers is that the amounts are not always balanced in a way that really make them ideal to meet crop needs. For example, meeting the nutrient requirement for nitrogen with a type of manure may result in supplying too much phosphorus. So I'd like to walk through just a few helpful resources that are good guides to navigating these complexities when you're putting together a nutrient budget. And there's a handful of those resources in the Google Drive, and they have tables listing the nutrient values of different common organic amendments that you can plug into your calculations. And some of these tables also predict what percentage of nitrogen will be released during that season for different amendments, or have notes on just the general availability of nutrients over the course of months or years for different amendments. So using those tables, you'll be able to estimate the amounts of nitrogen, phosphorus, and potassium that would be supplied during the season to your crop. And a few of those really helpful tables are found in this, this guide, the Fertilizing with Manure and Other Organic Amendments. And this guide is really helpful in laying out important characteristics of manures versus composts, and how manures and composts can vary depending on animal type or bedding material or how it's stored. And also it'll walk you through how to take a manure or compost sample and interpret your lab results. And then finally, it'll help you with step-by-step guide on how to calibrate an application of manure or compost. So those are all tricky things, and they do this guide really does a great job of walking you through the details of how to do all of that. So let's look at one of the tables from this publication just to highlight a few important points. This table shows nutrient values for a wide range of different animal manures. So this is uncomposted animal manures. And the first three columns list typical values for N, P, and K in different manures. And it's important to note that manure and compost analyses are generally read a little bit differently than fertilizer analysis. Not always, but sometimes. So it's important to be aware. Manure and compost P and K values are sometimes not given with that convention we talked about, where P is expressed in units of PTO5 and K is expressed as K2O. So it's just important to check the fine print of whatever table you're reading or your analysis from the lab. And but if you do run into a situation where you do need to make a conversion, it's real simple, and I've included it here for you, and it's also in the calculator. So let's see. So the next important piece that you can gain from these tables are the estimates of what percent of the total nitrogen from the first column is actually available to the crop during the season. So you'll note here that our table says, well, you're going to get 56 pounds of nitrogen from a ton of broiler chicken manure. But if you go over to this column, you'll note that, oh, well, actually only 40 to 60% of that nitrogen will actually be available to the crop that first season. So obviously that's a really important detail to be aware of and to take into consideration for your budgeting. So from the tables in this publication, you can determine estimates for N, P, and K and plug them into your nutrient budget. They've got this resource has a number of tables for composted animal manures as well as the uncomposted, and really walks you through some of the key differences to be aware of. So here is what plugging in values for a manure compost would look like. So in the calculator that I have, I like to note the analysis from the lab first. So that's where I would put, I would want to note that first, and then next I would want to note, well, what's the analysis based on the information from the resource we were just looking at for how much nitrogen will actually be available that first year. And so that's the second analysis that I like to note, just to make things clear for myself. And we noted that the WSU guide says, well, only 30 to 40% of the nitrogen from a manure compost will actually be available that first year. So that's the amount that I'm going to plug into my calculator, as opposed to that that higher value. And here the calculator tells me if I apply 8,000 pounds of composted chicken manure, that I'll be adding 24 pounds of nitrogen, 100 pounds of phosphorus, and 48 pounds of potassium, roughly. So that's how that looks. So like I said, I encourage you to dig into this WSU guide and the others when you have time. And a few other takeaways that are covered in detail from this fertilizing with manure and other organic amendments are that that manures tend to have higher nutrient content that is available more quickly, whereas composted manures have lower nutrient content that it tends to be released more slowly. Also, that they note that the carbon in manures tends to be less stable, and much is lost during the process of decomposition by soil microbes in your field. And whereas the carbon that you're adding in the form of compost has already been worked upon by soil microbes, and so it's more likely to end up in your soil pools of more stable organic matter. So generally, we think of manure more as a fertilizer and compost more as a soil builder, with those more long-term benefits to soil health and nutrient supply. And the guide also really stresses that because compost and manures are really so variable, it really pays if you're getting a consistent, if you're sourcing your manure or compost from a consistent source, to go through the process of getting it tested so you really know what you're applying. So you can also use the tables and the resources to estimate what nutrients will be available from other organic amendments outside of compost and manures. So this is a table from Doug Collins' publication. And say we're trying to use feather meal to meet some of our nitrogen requirement. And so we'll see that the analysis for feather meal comes in on the bag at 1300, but Doug here is telling us, well, actually just 75% of that nitrogen will be available during the first season. So we're going to want to make an adjustment in our understanding of the analysis of that feather meal and make sure we plug that into our calculator. So going back to our spreadsheet calculator example for the Brussels sprouts, we'll be adding the feather meal calculations here. And in the analysis section, I'll note both the analysis from the fertilizer bag, that 1300, but I'm also going to note that the adjusted analysis will actually be more like a 1000, and those are the values that I'll plug into the columns here to get an estimate of what I'm actually adding to my soil. And I'm also going to add values for bone meal, which will add some nitrogen, as well as phosphate and potassium. So that's where this goes. And note, I've also adjusted the analysis from the bag to reflect the information gained from some of those tables in those resources to really get at a better understanding of how much I'm adding to the soil. And so finally, for this example, we'll add a little sulfate of potash to get at the potassium. So once you've entered all that, the soil calculator will just crunch those numbers through for you, and then you'll have a total additions here down at the bottom, and then you can play with it as you like, and toggle things around till you get to a spot where you're happy with what you're adding. So so here's, just to kind of recap, here's the completed nutrient balance calculation for those Brussels sprouts. So we've entered our soil test values in the first section, and the soil test values for nitrogen and soil organic matter enabled us to estimate, well, what nitrogen credits can we count on for our crop? And those are found in the credits section of the nutrient resources here. So those are the numbers that we calculated for that from the soil test analysis. And then while we don't enter values for phosphorus and potassium amounts in the credits section like we do for nitrogen, we use the soil test levels for those nutrients to estimate what amounts of both should be added to the soil based on those indices that we talked about. And we enter that in the recommended nutrients to meet yield section. Then remember too, we've also added an estimate of how much nitrogen we might expect from a cover crop, and we put that into our credits section as well. And then we've calculated what nutrients will be available from a combination of different organic amendments in the final section, including a manure compost. So what's our predicted result from all of these calculations? It looks like our predicted nutrient balance will be calculated down here, right way at the bottom. And from this scenario, it looks like we're a little over on nitrogen, but a little under on both phosphorus and potassium. But if we're taking the nitrogen credit from our soil test with a grain of salt, we may not worry very much about overshooting a little bit, because we're really not sure if what we're gonna be getting in terms of nitrogen. So it's probably good to have a little bit of a cushion. And while we might want to increase our amendment rates to increase our phosphorus and potassium additions, you could also choose just to see how your crop responds to the current rate that you've determined, and increase it based on actual observation as you see how the crop does with that rate. So that's a real quick overview of all the different pieces of putting together a nutrient budget. So we've looked at the short-term aspect of nutrient budgeting with organic amendments, and just to wrap up, I'd like to just pivot a little bit and think a little bit more long-term. So we've spent some time wrapping our heads around the idea that not all the nutrients from our current season applications of organic amendments will actually be available to the crop. So, how do we think about that portion of organic material that we're adding each year that is not contributing to this season's nutrient budget? Here, this is a great visual on how to think about and account for plant available nitrogen that will be available for future cropping seasons from your yearly additions of organic amendments. It's from a publication in your resources folder entitled Soil Nitrate Testing for the Willamette Valley vegetable production. And it's a really super publication to dig into later. But this here, they've given us a representative of 5 years where the same amount of organic amendment is added each year. And in year 5, you see that the plant available nitrogen from previous year's organic amendment applications is really about equal to what the current year's edition of organic amendment application is. So it just is a nice visual to sort of understand, well, how does in adding regular additions of organic material, how does that sort of play out over the years? And after a while, you're really starting to benefit from these yearly investments of adding organic matter each year. And this visual from the same publication takes that concept from the previous slide and really helps us visualize a progression where fewer and fewer organic inputs are needed. So this figure shows a progression from a conventional system, say, where all of the crop nitrogen requirement is met with synthetic fertilizer, to all the way to a system where you're not adding any additional amendments. You're just counting on the soil organic matter mineralizing and providing those nutrients for your crop. So as you can see, when nitrate from soil organic matter mineralization increases over time, new organic inputs can be reduced steadily. So perhaps you invest, say, in large inputs of compost for a year or two, with the result that more of your nitrogen needs are met with soil organic matter mineralization in subsequent years. Then as you continue to build soil organic matter with cover cropping and dial in how to supply nitrogen needs from cover crops, maybe you can even drop the organic fertilizer applications out altogether or from time to time. However, it's really important, though, to note that meeting a large portion of your nitrogen needs via mineralization of organic matter can present some problems too. So most crops take up large amounts of nitrogen just for a short period, say like 4 to 8 weeks, but the mineralization from nitrogen from the soil organic matter won't turn off when your crop is done maturing. It'll continue to mineralize and release nitrate during all the way till the end of summer. And so you may find yourself in a situation where you're actually producing a lot of excess nitrate that can be then lost and leached out of your system in the fall when the rains come, and that can present problems for water quality, of course. Also, supplying more nitrogen to a crop than is needed, if you're really overdoing it and meeting all your need through soil organic mineralization, you may actually run into problems where you're delaying crop maturity and maybe even increasing crop susceptibility to pest and disease. So for those reasons, generally it's recommended to kind of find a sweet spot within, say, like system 3 or system 4, and to not push things so far that that you're really relying on all of your inputs or all of your nutrients being supplied via the soil organic mineralization. And it's pretty hard to get there, so most of us aren't in too much danger of that, but especially in some of our really intensive small scale systems, it can be easier to get yourself into that 5th system, which isn't necessarily advised. So so the take-home message really is that a balanced approach is needed to long-term balancing, and that your end goals will really vary based on your size and the overall characteristics of your cropping system. And as you navigate nutrient budgeting and determining, what those long-term goals of your system should look like, this guide that we pulled those visuals from is really, really helpful. It lays out several approaches for soil testing for nitrogen at various points in the season to really dial in when your crop is needing the nitrogen, and whether the inputs that you're providing are really strategic for your system. And then, of course, another standard way to track the nutrient balance of your system is to just perform soil tests in the fall to gauge how much nitrate remains unused in the soil before the rains leach it out. And if there's a lot left, then you know that you need to start dialing things back and finding a little bit more balance. So that is the end of the presentation I had for you tonight. I hope you're able to take away some new insights, and I especially hope the resources we reviewed will enable you to do nutrient budgeting with confidence. And while we can't expect to execute a perfect nutrient budget in the field, going through the exercise will help give us a general target to aim at, and then give us a starting point for adjusting our nutrient program according to what we see in the field and the shifts that we see on our soil tests through the years. So that's all I had for you tonight, and I hope we still have some time for questions. Oh, we're right at 8. So I went a little long, and thanks for your patience listening to that very long presentation. And if we could spend some time doing going through Levi's post workshop survey, that would be awesome. And then I'm happy to stick around, and we can field some questions. Levi's been watching the chat for those questions, and we can take some time to talk through those.
Yeah, there's no questions so far in the chat. But yeah, I was thinking if people do have time, I'll send the poll back out, and then while people are doing the polls and stuff, if they have any questions they want to just kind of say them. I don't know how you want to do it. Say them, raise their hand, put it in the chat, or whatever works. But I'll send out the poll right now, and then.
Yeah.
There was one question that popped up in the chat, Allie. I don't know.
Oh yeah. So I had a covered crop of annual and perennial rye in all summer and kept it mowed. Does that affect the loss of nitrogen? Yeah, so I mean, I think in terms of thinking about whether nitrogen is lost, it's not really lost from the system, but where our discussion sort of centered around is it lost to the subsequent crop. So if you wanted to follow that 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 cover crop with a cash crop, you should expect that there is going to be a little bit of you're going to have to add a little bit of extra nitrogen because there won't be enough for the microbes to do their work of decomposing the cover crop without pulling nitrogen from the soil. So that's, you just have to make sure you consider that in your nutrient budgeting. Does that make sense? Or, but if you just have a continual system of rye, like you described, then that it's a great scenario. You're still keeping all your nutrients in the system, and they're cycling through. The problem really just comes if you're trying to follow that with anything and you've plowed down that cover crop. And see, any suggestions for what to do if your soil lab uses different extraction than weak bray? Well, so if you're on the east side, then you will use the other reading there for phosphorus. So your soil test, your soil lab will know what's appropriate for your region, and they'll give you that guidance. So, and that shouldn't affect your ability to use the Excel file for nutrient budgeting. The guide in your resource folder, the OSU guide to interpreting soil test analysis, they'll walk you through that, and they don't in that guide they don't distinguish whether you're using the weak bray or the other. They just say whatever one you're supposed to use for your region, just plug that into the or use that for those determining how much phosphorus you should add to your soil. Let's see. I don't think there's any, I don't see any other questions. Feel free to unmute yourself too and ask anything. So it's sort of a lot of information to go through, and hopefully you'll find time to kind of dig into those resources more on your own. And but it can be kind of intimidating, but once you kind of go through it a couple times, then you'll feel a lot more confident.
So Allie, this is Diane Fish at Kitsap Conservation District.
Hey,
I know
Diane.
I know one of the things that's always a factor for me is looking at the cost of the various nutrients.
Yeah.
And so is there a piece to the calculator that allows you to do a cost analysis of, say, feather meal over bulk chicken manure? Or
yeah, that would be a really easy thing to add. I should definitely do that. I could add a piece in where it would calculate the cost of a pound of nitrogen, a pound of phosphorus, a pound of potassium for each amendment. So you could toggle through and kind of base your decision on cost as well. Yeah, that's definitely a thing that I should add. Well, any other burning questions about nutrients? And feel free to reach out with any questions later. Oh, here's one. It says, how do you know if your calculation was correct or how off it was? Oh, so at the bottom of that main tab in the calculator, it'll spit out a nutrient balance for you. So if it's negative, if one of the values is negative, that'll be an indicator of, oh, maybe I need to add a little bit more of something. Or if it's too far positive, then you maybe want to back down on one of your amendments.
So this is totally geeking out, but one of the thoughts that occurs to me looking at the WSU long-term study where they had the livestock rotation in their no-till cover crop trials that they were doing.
Yeah.
You know, if I mean, because doing farm planning, we always calculate, like pastured animals and how much
Hmm.
uptake in nutrient is there. So that would be another like layer. Or,
Yeah.
sewer, like, so say you're running pastured broilers over a section that you're
Mhm.
then going to be looking at, yeah, and then you could catch that with a soil test.
Yeah.
Now, one thing, and maybe I missed this, but I know that from a cover cropping perspective, one of the things that we do is we plant a cover crop to hold the soil and hold the nutrients, so
Mhm.
that we are able to bank some nutrients there. Is there any resource that allows you to like look at the potential nutrient loss or maintenance with that annual cover crop, or is that just you're better off just drawing a soil sample?
Yeah,
I mean, because there's stuff about the value of cover crop, right? So if you're doing like rye and field peas, or rye vetch, or whatever that looks like,
Mhm.
but also, I mean, if you're just planting the cover crop to just hold what nutrient remains.
Yeah, definitely. I mean, I guess it might be interesting to do an end of season soil test and see, how much nitrate do you have left over after your crop is all done. And if it's a lot, then that would be a real motivator to get a cover crop in as soon as you can to really capture all that nitrogen, that otherwise is just going to leach out of your system. Yeah. I mean, yeah, I mean, I guess if the nitrogen is in that soil that will be lost otherwise, and the cover crop it is available for the cover crop to pull up, then there should be more higher nutrient content in that cover crop to some extent. And I think something that's interesting to think about too is a lot of times our cover crops will look a little sad, and uh, it's actually important to think about fertilizing your cover crop. Not too much, obviously, but you can really see some benefit from just adding even just a little bit of nitrogen um, ahead of that cover crop. It really helps in certain situations on poor soils, especially, obviously. And then the cover crop is really able to put on the biomass that it has the potential to do, and then you have much more to incorporate into your soil in the spring. Yeah. Any other questions or deep thoughts on nutrients? Well, thanks so much for tuning in, and I hope we can do it in person again, in person, but maybe we'll continue to do in person and Zoom so we can get everybody in. So. Cool. Levi, were you able to get your survey all buttoned
Yep.
up? Awesome.
Yep, everyone filled it out, so perfect. Thanks again.
Awesome. Thank you all so much for taking the time to do our survey as well. We really appreciate it. So with that, I'll close our webinar.
Awesome. Thanks, Allie.
Yeah. Take care. I guess, Levi, do we need to save it at this point before we close it out?
Well, mine says leave meeting, so I was gonna wait to see what happens when you leave the meeting and see what the recording does.
Okay.
But it should just
Cool.
save to our cloud, like Nicole said.
Yeah. It seems like if that was selected, then it's good to go. Cool. Awesome. I'll get out of here and see you tomorrow, maybe.
Yeah. Thanks, Allie.
Okay. Bye-bye.